Okay, Algebra 2 students, this is the first lesson on the first video for lesson 2.4, complex numbers and operations. The essential question, how can you represent and operate on numbers that are not on the real number line? Vocab, we're going to learn about the complex conjugate, the complex number, imaginary number, and imaginary unit. And in the end, you'll be able to solve problems with complex numbers. Moving on to example 1. Solve a quadratic equation using square roots. So here we have a straightforward quadratic equation, the x squared equals 16. Notice each side of the equation involves a perfect square. X squared is perfect square, and so is 16. So when you take the square root of both sides, you get x and the square root of 16. We got to consider the positive and the negative case. You can have positive or negative 4. So the solutions to the equation x squared equals 16 are positive and negative 4. Now here's another one, except it's negative 9. There are no real numbers that you can square to result in negative 9. However, you can simplify the expression by extending the properties of radicals. Let's see how complex they make this. They might make it more complex than they need to. So x squared equals negative 9. So x equals the square root, positive or negative square root of negative 9. Now we can break the negative 9 into 9 times negative 1. The square root of 9 is 3. So here we have x equals positive or negative 3 times the square root of negative 1. That's what the issue is the negative 1. Well, it turns out at some point somebody a while ago created an identity for the square root of negative 1. And they call it an imaginary unit. Let's see right here. The number the square root of negative 1 is called the imaginary unit I. So replacing the square root of negative 1 with an I allows you to write the solution for x squared equals negative 9 as 3i and negative 3i. So if you ever have a problem where you're taking the square root and it's a square root of a negative, I can't really highlight that, square root of a negative, you're going to break it down into I, this is I, and whatever this ends up being. So this is why it was positive and negative 3i. Okay, that's the new concept, big concept for this section. If that made sense to you, you can go ahead and try these two problems. Trying to find this x squared equals negative 5. What are the roots of that, or what are the values of x that work for that? And for negative 2, click negative 72. Click pause and come on back when you're ready. I don't remember if I don't think I created a blank sheet, so yes I did. All right. When I take the square root of both sides, I get x equals the square root of negative 5. So I'm going to break that negative 5 into the square root of negative 1, hopefully, excuse me, times the square root of 5. Now the square root of 5 doesn't break down, but this becomes, let me change colors for effect, this becomes I, and I forgot we need to account for negative and positive that. So the answer, I already have it right here, x equals positive or negative I times the square root of 5. Okay, there's that one. The other one they asked us to solve for was the square root of 72. This breaks down into x times, when you take the square root, you get the square root of negative 72. That can be broken down into square root of negative 1 times square root of 72. And I'm not sure how exact they got, but in pure mathematics, square root of 72 would break down into 36 times 2. The reason why I did that is because the square root of 36 I know is 6, but I can't break down the square root of 2. And the square root of negative 1 is I. And then once again I forgot positive or negative. So my final answer to this is going to be positive or negative. The square root of 36 is 6, and I have the I. It's always good to write if it's not in the square root, to write that number out front, and then the I, and then square root of 2. And I'm not sure if that answer key went with that, so let's look how they wrote their two answers. For the first one, they wrote, as I did, I square roots of 5. They didn't write positive or negative, though. Why did they not write that? Use square roots to solve the equation. Write your solutions using the imaginary unit. I think they forgot the negative value. And then for this one, 6i square roots of 2. Once again, they did not write negative 6i square roots of 2, which they should have. And that's it. Let's see what problems your teacher can assign to you. 14, 15, 16, 17, 48, 10, and 12. That's it for this video. Have a great day.